Hi, we are back with SLO 22, Part 2. Again, the goal of this video is to write a polar equation of a given polar graph. In this case, we are starting with lemniscates because the previous video focused on circles and limicons. So let's get right in. So the general form of lemniscates is r squared is equal to a squared sine 2 theta. The length of each loop is based on the value of a. In this case, we have 2. And so we're using sine here, meaning sine is symmetrical to the poles. However, it doesn't go through either of the axes, which is what we'll see with cosine. So cosine here, we have r squared is equal to 1.5 squared cosine 2 theta. So cosine goes through the x-axis. The length of the loop corresponds to the value of a. This is 1.5. And cosine is symmetrical to many things: the poles, the x-axis, and the y-axis. Let's look at another example. So we're going to find the equation of this graph. As we can see, this graph is symmetrical to the x-axis and the y-axis and the poles, meaning we're using cosine. However, in a positive cosine lemniscate, it will be around this area. It will focus along the x-axis, meaning we have a negative involved here. The length of each loop is 4. And so knowing all of this, we can put it together to create an equation. So we'll have r squared is equal to -4 squared cosine 2 theta. We're now going to move on to Rose curves, which have some variation to them overall. So Rose curves are a petally shaped kind of graph. So for this one, we have r equals 2 cosine 3 theta. So remember, in a Rose curve, you can change the a value here and the n value here. So a matches the length of each of these loops, each of these petals, really. So in this case, this petal is 2 because of the a value here, and the n is odd in this case. The n represents the number of petals. So since it's odd, the number of petals will correspond to n. Cosine indicates the graph is symmetrical to the x-axis, so we'll see some symmetry along this way, but sine is different. Let's look at Rose curves for sine. So in this Rose curve, we have r equals 4 sine 2 theta. Again, a matches the length of the loops, so as we can see here, the loops go out to 4, the petals go out to 4. N is even in this case, so we have 2 theta in the parentheses here, meaning that we'll have double the value of n, so n is 2, meaning we'll have 4 petals. And sine indicates that the graph is symmetrical to the y-axis. In this case, there is an even number of petals, so it's harder to tell. However, it doesn't directly go through the x-axis, meaning that it's sine. Let's try and find the equation of a Rose curve. We know we have a Rose curve here, so let's observe some things about it. A matches the length of the loops, so each petal, each loop goes out to 2. We have 1, 2, 3, 4, 5 petals, meaning n is odd. So the number of petals will correspond to the exact value of n. So in this case, n is 5. This is symmetrical to the y-axis and does not go through the x-axis at all, meaning we're using sine. So our equation equals y equals 2 sine 5 theta. So this covers lemniscates and Rose curves. This finishes SLO 22, Part 2. Again, all of the graphs I have here are from Desmos. Thank you for watching and have a good day.